Whipping up a dessert used to take a fair bit of muscle power, until a mixer with a motor was invented in the early part of the 20th century. The first ones were very industrial looking and not much like today's sleek models. But with this invention, the job of baking is a piece of cake. Today's mixers can whisk you into a world of culinary delight. To make one, a machine straightens wire between rows of wheels. Computer-programmed forming tools make 12 bends to produce shapes, which will be used to build a whip attachment for the mixer. To assemble a whip, a technician fits the wire arcs into an aluminium hub, starting with the largest one and graduating down to the smallest. Underneath, a punch mechanism dimples the hub to fasten each wire to it. Here, dough hooks and beaters are dropped into a vibrating bowl full of metal nuggets. The friction polishes these zinc mixer attachments and gets rid of the sharp edges. Next, a band of aluminium is threaded into a machine that bends it to the contour of the mixer. This piece of trim carries the brand name. A bowl feeder now funnels hollow iron weights towards a system that threads wire through each one of them. Mechanical arms pinch and bend the wire, making small hooks on the ends. 2 of these weights will be used in each speed governor, the device which keeps the mixer's speed constant despite changes in the load. To assemble the speed governor, they arrange a brass hub, spring and a washer in a holding device and then press fit them together. The 2 weights are attached to the spring assembly using the protruding wires. The speed governor system is now complete. Here's how the governor weights fly out to regulate the mixer's speed. It's now time to prepare the motor shaft. This spinning steel cylinder is lowered to a revolving cutter. Lubricant keeps the cutter cool as it carves spirals into the end of the shaft. The spiraling grooves will allow the shaft to drive the mixer's internal gears. With its motor windings and bearings attached, the shaft is installed into the mixer body. Next, electrical contacts are riveted to plastic control boards. These contacts will conduct electricity to drive the motor. An electrical charge is delivered to the contacts to make sure they're working. Then, screws, nuts and springs are attached to complete the control board assembly. The control board will work in conjunction with the governor weights to control the mixer's speed. For these mixers to really shine, they'll need a good paint job. The mixer parts are polished on an abrasive belt to prepare them for painting. Then it's into the paint booth. This is a highly charged process. The paint has a positive electrical charge and is attracted to the zinc mixer parts, which are negatively charged. Now all the parts are in the mix. And coming up next, we'll show you how they all come together. Behind many a successful cook is a well-oiled machine that's made for speed. And that's the electric mixer. It produces the best results when the blades turn rapidly. If they turn too slowly, they won't mix the batter thoroughly. And that means your pastry could be a flop. To assemble this tilt-head mixer, a gear which will drive the attachments is installed. Next comes the stator, which creates the electrical field for the motor. A dab of oil is applied before the shaft and motor windings are mounted inside the unit. 2 motor brushes are slid into pre-drilled holes. The motor brushes will supply electricity to the internal components. This bearing bracket holds the motor in place. The front of it is lubricated and the electrical control board added. A trim band with the brand name on it is wrapped around the outside. Next, grease is poured into the section of the mixer that will hold the gears. The gear section will be sealed so the grease can't leak out. The other half of the unit, that already has some gears fixed to it, is attached. A drive pin that will move the whisk and other attachments is inserted in the shaft. More grease is applied to this section, and the 2 halves are screwed together. And then the planetary gear is installed. This gear will rotate the mixer attachments around the bowl. A pin is hammered in place to attach the planetary gear. A decorative ring is tapped onto the outside. The motor unit is mounted to the base, and an identification number is marked onto the bottom. Now the tilt-head mixer goes for a spin. The next step is to adjust the speed. The technician installs a speed-setting tool in the hub of the mixer. While the gears turn, he checks the readout and tunes it up. Each mixer has to be able to make a dizzying 200 rotations every minute. The hub is capped. The final step is to test the beater. It must be correctly positioned above the bowl. One last polish, and it's ready. Over at another station, a more commercial type of food mixer is being made. One with a bowl that lifts to the beater instead of a tilt head that lowers to the bowl. A base is screwed to a bowl support piece. Then the lower housing for the beater motor is attached. As the mixer moves on a conveyor, the motor and gears are installed. A generous squirt of grease is used to lubricate the transmission. And then the top of the motor is encased with more housing. Continuing down the line, the electrical speed controls are installed and topped off with more housing. The signature piece of trim is wrapped around it. The wattage and speed are checked using a probe. It passes inspection and it's ready for packing. It's taken approximately 10 minutes to assemble this mixer, but it's been made to last a lifetime. And with such a wide range of attachments for these mixers, you really can go stir crazy.